Hello everyone, we're here to show you Group 7's midterm review video. The United States in the 19th century was a vastly different place. By today's standards, the technology and economy was quite primitive, with 90% of Americans working in agriculture. Formal education was rare, with it mostly aiming to train people in law, medicine, or ministry. Two engineering traditions are abound in Europe. The French tradition, owing its origins to military and state operations. Education to French engineers was pivotal, so the French engineers developed a curriculum for the profession, and most engineers came from a higher social rank, causing the profession to be held in higher esteem. Contrast this to the British tradition, which was driven more by the needs of businesses and less by the needs of the state. The rank of engineers were filled with working class and blue-collar folk, and they emphasized tinkering, less of why things worked and more of how things worked. And given all this and the lack of education, engineers were held in lower prestige in Britain than they were in France. Combining both the French and the British engineering traditions created a uniquely American engineering tradition. This dates as far back as the American Revolutionary War, when France deployed 24 military engineers, who brought with them, of course, the French engineering tradition, but later combined with future civil engineering projects to create this American tradition. One of the earliest and most notable of these projects was the Erie Canal. Some call it America's first school of engineering, and it was a great civil works project to combine New York City to the Great Lakes to reduce the cost of transport and trade. Many key innovations came from the Erie Canal. Hydraulic cements, for example, were used to help keep the canal walls from leaking. Aqueducts were utilized to redirect the flow of water. Locks allowed boats to traverse up and down in elevation. And the Niagara Escarpment was a very unique challenge, which helped develop new ways of blasting and moving rock, as well as pulling stumps. Some of the key figures that were in the Erie Canal Development Project were William Weston, who is a British engineer who was brought in to help collaborate on the Erie Canal. He later went on to train Benjamin Wright, who was later dubbed the American Father of Civil Engineering. James Geddes learned the craft of engineering on the job. And Canvas White traveled to Britain to learn special engineering techniques and help develop hydraulic cements. Meanwhile, John Jervis is a great example of an engineer working up through the ranks from laborer all the way to full-blown civil engineer.
With the expanding growth into the West, the United States needed more engineers than ever. The demand for them was at its height during the Civil War. After the Civil War, America exploded in technology from a more complex rail system to the telegraph, the telephone, and the electrical grids that we see today. This growth of engineers in America is due in large part to West Point Academy, which is considered America's first school of engineering, with most of the graduates joining the Army. But once the Army could not take any more graduates, the graduates then turned to the private sector, with more schools starting to open, like Harvard, Northwich University, and Rochester University, just to name a few. These openings are due to the Morrell Land Grant. But with so many new people in the industry, there needed to be representation. These times, several engineering schools formed. The ASCE, AIME, ASME, and AIEE were considered the first four professional societies for engineers. Each of these four different groups all had different standards for what it was to be expected of their members. The ASCE, for example, were a society that held high value on an engineer not participating in judicial courts and had 3 membership tiers, all based upon experience. On the other hand, the AIME focused on business and were very lax on their membership requirements. The ultimate goal of these societies was to promote the individual engineer through prestige and reputation rather than corporate connections. With better educational resources, societal representation, and social prestige, civil engineering went from around 300 local farmers adapting to their environment in the late 1800s to over 226,000 in 1930, thus starting the Great Engineering Explosion.
Unit 3, Patterns of Invention, Independent Inventors, and Industrial Research Labs. The linear model. A model that is used to expand scientific basic research. The basis of this research is a federal or business funding that goes to basic research, which then creates applied research, which could create a development or technology that is used to create social benefit through the application of this new technology. Vannevar Bush helped expand this after World War II, as it was seen as an effective model to help create new technologies that benefited society. This isn't the best model that explains how technology is created, though, and is generally seen as a flawed way of explaining the innovation process. Tinkering with technology generally creates a large amount of technological gain. Independent inventors generally had small teams that helped create radical inventions that would create whole new industries. A good example of this was when Thomas Edison and his invention of the light bulb also had to create a power plant to create electricity, a method to transport the electricity produced, and consumers to consume the electricity. Characteristics of independent inventors. They generally grew up in rural areas. They generally lacked formal education but showed technical prowess at an early ages. Most independent inventors would blend scientific method and empirical trial and error methods to get a finished product. The hardest challenges they faced was the constant requirement of additional funds to help pay for teams they hired, materials they used, and many other costs. Most of the funding came from jobs they worked on the side, patents they sold to local businesses, and wealthy patrons willing to sponsor them. Then it became a marketing gamble to create your technology and convince people to use it in society. Industrial research labs are heavily funded corporate research labs dedicated generally to the field of industry that produced conservative inventions. These inventions were generally focused on improving already developed industries rather than revolutionizing a new one. These industries became more and more complex and required greater amount of resources to tinker and develop new technologies or improvements, especially with trained engineers. Industrial research labs are heavily funded corporate research labs dedicated to generally a field of industry that produced conservative inventions. These inventions were generally focused on improving already developed industries rather than revolutionizing a new one. These industries became more and more complex and required a great amount of resources to tinker and develop new technologies or improvements, especially with trained engineers. Research labs, such as Bell Labs, created several conservative inventions in the 1930s. They had a greater ability to create inventions due to large staff, constant financial support, and the ability to hire a large amount of skilled technicians and theorists, which helped create complex systems and conservative inventions to thrive. This all led to the rise of demand for engineers in the early 20th century, but also restricted engineers into teams and tied them to companies. Engineers would produce products for companies for more often than producing independently, which allowed corporations to grow exceptionally well during this period. The independence of engineers fell during this time as well. Thank you for watching our midterm presentation.